Day 65, Honors Physics, Uniform Circular Motion, problem number 22. First thing you need to do here, or one of the first things you can do, is find the tangential velocity, which is pretty fast actually for a Ferris wheel, but I just did at the top here the distance over the time, taking the distance as one circle, 2 pi r, divided by the time it takes to make one full revolution, 7.5 seconds. Tangential speed of 8.37 meters per second. Once again, that's pretty fast for a Ferris wheel. When you're at the top over here, on the left, part A, there are two essential forces acting on you. The force of gravity down, which is not going to change, but the force of the seat is up always. It's the normal force. But as you're going around over the top of a circle, that force is less than the force of gravity because your net force, the centripetal force, has to be towards the center, which is down here, because you have to have an acceleration in that direction. You will have an acceleration in that direction, centripetal acceleration. But bottom line, Newton's second law, F net equals ma. F net is the bigger force, force of gravity, minus the force of your seat, is the net force, equals mv squared over r, because acceleration is v squared over r, centripetal acceleration. So force of gravity is your mass times 9.8, minus the force of seat, which we're looking for, is mv squared over r. Solve for force of seat. Another way to think about this problem is, even like if you're in a regular car and you go over a bump real fast, you feel lighter for a few seconds. Or a roller coaster, if you go over the top of a hill, you're going to feel light. Even though your weight hasn't changed, your force of gravity isn't going to change, the force the seat is exerting on you changes, and that's the feeling that you have about your weight. If you go over the top of a hill, you crest a hill real fast, you'll feel a little bit lighter. The opposite happens at the bottom over here. At the bottom, once again, the center of the circle is up here above you. Force of gravity hasn't changed. It's still down, same magnitude as before, but the force of seat is now greater. Once again, think about this. When you go into a dip on a roller coaster or in a car, you feel a little heavier for a brief moment because the seat has to exert a bigger force on you than gravity. It's F net equals ma. Same thing now, except for force of seat is the bigger force. Big force minus the smaller force equals the mass times the acceleration. Just plug all those numbers in. The only thing you do not know is the force of the seat, minus the force of gravity, which is your mass, times the acceleration due to gravity. I'll let you plug all the numbers in and figure out the force of the seat.